Hello and thank you for attending today's webinar on data center ambient cooling. The webinar today will be approximately 45 minutes long, followed by a Q&A session. If you have any questions during the webinar, please use the box in the upper right corner of your screen to submit them. All questions will remain anonymous and will only be seen by the presenter. After the webinar concludes, I will be sending out an email with a certificate of attendance, a video of this presentation, and a link to next week's webinar on louvers presented by Ruskin product experts James Livingston and Tiffany Wright. Thank you again for attending, and I will now turn it over to Gaston to begin the presentation.
Thank you, Emma. Hello, everyone. My name is Gaston Khatib. I'm new at Ruskin. I've been here with the company for a few months now, working as a regional sales manager, supporting Ruskin products in the Western States and Western Canada. Prior to that, I worked as a sales manager and application engineer, supporting sales of underfloor air distribution products for about 11 years. And prior to that, I worked as a consulting engineer, designing different mechanical systems for about 13 years. Today, we'll talk about data centers. We'll go over the common practices that we see with these systems. We'll go over the HVAC systems, some of the do and don'ts. We'll touch in greater detail about one of the strategies, and that's using 100% outside air as a good kind of opportunity to save energy in a system layout. We'll also talk about some of the Ruskin products that we recommend with this application, and then we'll go over some of the case studies. So why data centers? If you kind of think about, if you're at home and think about how many devices you have connected to the internet now versus what you had 5 years ago, you get an appreciation to all that digital information that needs to be stored somewhere, that needs to be handled somehow. If you think about the way we shop now versus how we used to do 5 years ago, you would again get an appreciation for all that digital information and the clouds and the servers form. We really see a lot of activities on data centers. They are projected to double next year from what they were back in 5 years ago. Now these are specifically made to house servers and IT equipment that like hyperscale. They really consume a lot of energy, and there has been a push to reduce the energy usage on them. There's also, since we're making a lot of them, a lot of them are being built. There's really been a kind of we know how these are constructed now. They're being designed better, constructed faster. So there has been a push to also reduce the cost in all of these data centers. So from an HVAC point of view, looking at the design, the number one goal is to make them reliable, and that's to prevent failure, right? That HVAC system is going to support that data center, and it's going to make sure that the environment is maintained so the data centers are working. That's the number one goal, and that's what really makes them, it's a mission critical, and it's a risk management to ensure that they're operating correctly. That HVAC system also needs to continue to operate 24 hours a day, 7 days a week. That system needs to be redundant to prevent, to handle the risk management, but also it needs to be flexible. Now it's flexible not from the sense of just when laying out these systems, servers, data centers, they tend to update the servers inside that hole, and it's not unusual to reconfigure the entire equipment once or every couple of years. So that HVAC system has to be kind of designed to support that different load from different equipment. Now these servers are not going to be loaded 100% all the time. That the loading on them is going to vary depending on time of day, depending on time of year. So that HVAC system also needs to kind of handle that variance and load. It needs to be modular, so as you bring in more of these servers online, perhaps you've got the entire data center occupied, perhaps you've got only bays of that server where you're going to have bays of that data center where you're going to have those servers in there. So that HV system needs to be responsive to that variance in load. You also need to obviously consume less energy, make it very energy efficient HVAC system, less expensive to operate, and faster to modify and adjust as needed. Now, the trend we see with these servers is that, you know, they used to be designed for 1 kW per rack, but the trend has been to increase the higher power density on them. And so it's very common now to see 10 kW per rack, 15 kW per rack, and even higher. That increase in power density also increases your HVAC load. Now, the push to also make sure that these data centers are energy efficient. And so there's a challenge, right? There's an extra load and also the energy efficiency. We'll touch base on some of those. So you might have seen PUE, the term. That's a term that got introduced back in 2013. It's really it's a power usage effectiveness. It's a matrix that measure how much power you're bringing into that facility and how much of that power you're going to be using to the IT equipment and server. So ideally, you want to be at 1. If you got renewable resource, maybe on-site, off-site, maybe that number gets to be lower, but ideally you want to be at 1. Now that the critical part of this is a performance metric. This is really done after the building is brought online and the facility online. It's not at a design standard. For the design standard, we recommend 90.4. So we're all familiar with 90.1. Back in 2016, ASHRAE pulled the data center buildings out of the 90.1 and made a standalone standard that's 90.4. It meant for data center buildings. We know because these buildings are really different from other commercial buildings. They've got a unique energy requirement and unique space set point. So just like 90.1, you have a set of maximum allowable values that are listed in the standard, and that's based on a climate zone. You comply with the standard when your calculated values do not exceed the values listed in that standard. And just like 90.1, there's an alternative compliance that you can take to do some trade-off to comply with the standard. So again, this is really an excellent source to use when designing, and not only designing, but also operating, maintaining, and perhaps utilizing some on-site, off-site renewable energy sources. All right, so we talked a little bit about the energy standards. We also talked about the push to reduce energy usage, yet at the same time we have a higher kW. So that's really a challenge. Now the good news is that these servers, they're really manufactured to operate in a much higher temperature set point. They also have relaxed humidity controls. Now, this is important really because it allows us to do 2 things. Now, if you have higher room temperature set point, your supply air temperature is going to be higher. That gives you an opportunity to improve on your energy efficiency of your HVAC equipment. But it also opened the door for other strategies or opportunities that perhaps may not be attainable when your set point was 55 degrees supply air temperature. Now we're bumping this out higher, so now we could use more kind of opportunities on that. And so we'll talk about 100% outside air economizer and the opportunity for it. But before I get into that, really want to kind of understand, as a design engineer, as a facility, we want to understand what servers and what manufacturer equipment you're serving and supporting. Kind of understand your audience when you're designing these systems. So ASH rate, technical committee 9.9, it's for mission critical facilities, data centers, technology spaces, electronic equipment. It really classify servers based on operating temperature. And so they have class A1, A2, A3, A4, they got B and C. Now these are classified based on the environment, on the allowed and recommended operating temperature and also humidity. Now most of the current data center equipment currently falls into class A1 and A2. There is a growing number of server manufacturers introducing equipment suited for class A3 and A4. But if you look at that quickly, let's say recommended A1 through A4, your temperature is anywhere set point from 64 to 81, and your relative humidity is 60%. We know it's not 55 degree and it's not 50%. Now, if you have other classification, like perhaps maybe A3, A4, you have the opportunity, you have a wider range in the temperature, and you have a wider range with the humidity, a much more relaxed controls on the humidity. Now, I say that, but we have to be very critical. Now, the number one in these mission critical facilities is to ensure that you're going to have a reliable system. So if you supply at the temperature too hot, if your set point is too hot or your supply air temperature too hot, you may have temperature induced failure because your temperature got too warm and your server failed or is not operating at ideal condition. It's not as fast as it needs to be. If you make the environment too dry, you might run into electrostatic discharge, ESD. And if you make it too cold, you might run into condensation, and that might create corrosion. Also, with 100% outside air, we're bringing a lot of air into that building. We want to make sure into that environment, we want to make sure that that air is filtered. So keep in mind what classification do you have or what class do you have from these server manufacturers, and also looking at kind of the allowed supply air temperature and relative humidity set point. And so yeah, there has been a lot of innovative designs on the HVAC system for data center. So which one is the best one to use? Well, you decide based on the climate you're in, based on the location, based on the design conditions that you have, on the equipment that you're going to be conditioning, and also what kind of utilities you have available. So this could be chilled water, this could be DX, this could be adiabatic cooling. That's very popular. We use evaporative cooling to adjust your dry pulp temperature. This could be an air side economizer, and that's where you disable your mechanical cooling and you bring in 100% outside air, and then use that basically ambient conditions to condition and cool the servers. This could also be water side economizer. This could be an underfloor with access floor. This could be in-row cooling. This could be a cold aisle, hot aisle. And again, you decide on the best system, or it could be a combination of those. So let's talk about 100% outside air, and that's again where you're utilizing your ambient conditions. So just like we talked about 55 degree set point versus 65 versus 75 versus allowed 81 degree. So let's take an example for an 81 degree set point. So that's we take an example for a data center operating 24 hours. 7 days a week. That's 8,760 hours per year of operation. We've got 81 degree dry bulb, 59 dew point. That's about 67 degree wet bulb, 47% relative humidity. And so when that condition is available, anything that's 81, 67 or below, And yeah, you might be using enthalpy and you're looking at enthalpy and making sure your humidity is right. But let's say we have 81, 67. And so when that condition is available, you can disable your mechanical cooling and just pull your outside air. And so the only energy you're using is moving that air, supply fan, perhaps a supply fan or an air handling unit, and then maybe a relief fan where you're pulling that air out of the building. Look at the hours. If you get a location in the dark blue, look at the hours that you could use with 8167. That's 8,000 hours of operation for the life of that data center. You're gonna basically disable your mechanical cooling 91% of the time and just pull that air. Look at an area in the red. So that's about 4,000 hours. That's about 50% of the time. So even in a hotter, warmer, more humid climate, with an 81 degree, you could disable your mechanical cooling and for 50% of the time use an air side, basically as a free cooling, and that's an excellent opportunity to reduce your energy usage. So for an example, let's take a data center, let's say 10 kW per rack. That works out to be about 1,000 CFM per rack, maybe about a 50 CFM per square foot of an airflow cooling density. That's how much area you're needing to handle those that data center. Now, to kind of give you something in comparison, a typical commercial office building might be using 1.5 CFM per square foot of an airflow cooling density. So you can quickly get an appreciation how much airflow you're needing for these data centers. Now, the good news in a data center, you have the room to install these louvers, so you can put your louver in a location and then pull all that outside air into that data center. For example, here, let's say in the kind of the blue area, we've got the mechanical room where we have the air handling unit and we're pulling outside air. And then we have supply air to that server. And then we're bringing that air in 100%, and then we're relieving that air out. And so we'll talk on the outside air damper, the intake. We'll go over some of the supply dampers, return, and relief. So again, for that example, we're looking at a cross section. You've got your server data center to the right, your mechanical room to the left. Maybe you've got two mechanical rooms, one on the right, one on the left, providing air to the server, to the data hall. You bring in your outside air, and that's going to have a louver and a modulating damper. And then you're going to basically modulate that damper from minimum, and that's ventilation air, to maximum, and that's when you're 100% outside air. The key is to size them so you have low pressure drop across it. The lower the pressure drop, the less resistance you're going to have, and that's going to give you an energy efficient and less less power usage at your supply fan. So I'm bringing in that outside air. I've got an air handling unit. When I'm an air side economizer, I'm going to disable my mechanical cooling and then pull that air into the data hall. That supply damper needs to be low, located close to the server rack. You might need to direct the air to the right, to the center, to the left to make sure you're serving the entire area. You also want to make sure that your throw of air is getting to the entire server rack, an entire row of servers. It's not only conditioned in the very first 5 or 6. So there's a close attention to be taken there. You got to reduce the pressure. Typically they're sized at about 1,000 feet per minute, maybe a little bit lower, maybe a little bit higher. Your pressure drop typically is about 0.01. And again, lower the pressure, the better it is for the energy efficiency of the system. And then you direct that air to the server. Then that air is going to come back, warmer air. Now the return, the higher, the better. That air is going to stratify up and it's going to make it back to the air handling unit. And so we size that return maybe at about 750 feet per minute, maybe at about 0.02 pressure drop. Now, the one thing to consider on that is basically that return is going to be closed when you're doing 100% outside airside economizer. But let's say you're doing 10% outside air, that return is going to be maybe open 80%, 85%, bringing the return back. You want to make sure that the return is sized so the pressure drop from the data hole back to the inlet of the air handling unit equal the same pressure drop from the ambient outside through the louver and dampers. So it kind of self-balance and help the test and balance adjust those dampers. What you do not want to do is open the outside air damper 10% and then yet get the majority of the air because you got a restriction in your return. So let's go back to the example of the 100% outside air. Your return is probably going to be closed. You're going to relieve that air out of the building, out of the data hole. So we're going to have a backdraft damper. These could be roof mounted. They could be mounted in the wall, or they could be mounted in the ceiling, and basically taking that air back and relieving it from the room. So that's really kind of an example. We kind of touch base on 100% outside air. It really is a good strategy to use. We encourage you to use. It gives you an opportunity to reduce your energy usage. And if you have a data center, we can definitely help with that. Call Ruskin, call our local rep, and we can help you with this. For now, I'm going to turn it to the second best looking regional sales manager, Spencer, and he can go over some of those details.
Okay, I see how it is, Ghassan. I see how it is. Hey everyone, thank you so much, and thanks, Ghassan. That was a lot of good information. My name is Spencer Brinkmeyer, and I am also a regional sales manager at Ruskin. Today, I'm going to talk a little more about Ruskin's specific solution to maximizing that outside airflow through your data center, as Ghassan suggested with the 100% outside air. And mainly what we'll be looking at here is louver and damper solution. So firstly, our most efficient louver recommendations for your data center applications are shown here in these photos. And these include the ELF 6350 DMP, the ELF 6375 DXH, and the EME 5625 MD. All of these models are made from extruded aluminum and are AMCA certified. So these are going to be your most three common louvers that you would see in data centers. So starting with the ELF 6350 DMP, it's one of our highest performing louvers because of its drainable blade design that actually channels water down the jam gutters and out the front of the louver. So this design provides excellent water penetration, and coupling that with its exceptional high free area at 62%, it is one of the most top specifiable models for louvers out there for data centers. Next up, the ELF 6375 DXH. This is slightly more robust while still maintaining that same high performance. It has an 1/8 inch thick frame and blade construction. And this model also offers excellent water penetration with 57% free area, also making it highly specifiable. So this also has more than 50% net free area. And due to its upgraded structure, this louver can also boast a higher wind load rating than the ELF 6350. And it makes it more suitable for multi-story structures where you're wind loading, the higher elevations is going to be a larger value. And then finally, the one on the right there, the EME 5625 MD. That MD does stand for Miami-Dade. So this is a vertical blade Miami-Dade rated louver that is designed specifically for keeping airborne debris out of your building. And this is not just for Miami, it's not just for Florida. This type of louver is ideal for installations where it's critical that the servers remain operational during a storm event. So this louver is approved for AMCA 540, which tests your impact resistance, and AMCA 550, which is your high velocity wind driven rain test. It's Miami-Dade certified, as I mentioned, as well as Florida approved. And this model offers excellent Class A wind-driven rain protection as well. So those are our three primary louver solutions in data centers. There are also instances where a specialty louver might be required to meet the needs of that specific data center project. So here are just three examples that we wanted to highlight in case you come across these situations. For tornado regions, such as the central United States, if you needed something even more robust than the Miami-Dade model I mentioned earlier, the XP 500 meets FEMA 361 design and construction for community shelters. It also meets ICC 500 for large missile impacts up to 300 PSF wind loading. This louver also has a UL listing, so it's still maintaining the strong performance and has a free area of 46%. The next one you see there, the EAL 6811, you might notice that louver model looks slightly different than the others. The blade you can see is a little bit thicker. That's because this is an acoustical louver. So not only is this one keeping rain out and allowing airflow in, but it's also attenuating the noise from inside the building. So this is important because a lot of data centers are located near either residential areas or business districts. And in these settings, the data centers must be designed to assure that the generator noise is not emitting noise pollution into those areas. You know, you get angry residents, angry, business professionals. So for that improved sound attenuation, the EAL 6811 is the choice for acoustical louvers in a data center. This model is also adjustable, so it can be modulated, open or closed based on the desired system pressure. We have several acoustical louver models, but this is our most economical acoustical louver model with a free area of 30%. And if an acoustical, one thing that's not shown here, and we haven't mentioned too much, if an acoustical louver alone is not enough to attenuate that noise, Ruskin, we also provide a extensive line of silencer products as well that you can combine either with your damper or your louver to mitigate that noise further. And then lastly there on the right, this is just actually a recent entry for us, is that we have combination louver and damper combination units, so that if space is a big requirement and you don't have the room to separate the louver and damper from each other, we can create a combination louver and damper. And what's new about this is we have recently come out with a full line of AMCA 540 and AMCA 550 combination louver dampers. So Ruskin has 4 Miami-Dade models that can be used for the combination, and also we have 2 enhanced protection louver models that can be used as well. And those we can combine with either a CD40, a CD50, or the SD60 Ruskin dampers. So that's mainly the louvers that you might see used in a data center. I wanted to mention a few dampers as well. So as most of you know, and Ghassan mentioned this, data centers require the HVAC systems and equipment to maintain consistent environmental conditions that ensure peak performance and reliability of the internal servers. So air control dampers, these play a vital role in these systems, and therefore these must perform at a high level always. Our newest data center models are all what we would consider our top performers, and we've taken base models but we've incorporated specific new and standardized features to ensure higher performance and feasibility within the data center. So we call these models the DC line, and you'll see all of them end in DC, which if you're really smart, you may have guessed DC stands for data center. And these were actually just introduced this past month as well. So all 3 models are energy efficient and AMCA certified to meet a class 1A leakage rating of no more than 3 cubic feet per minute per square foot at a 1-inch water gauge. And what you see here, we have the CD60 DC, the CD50 DC, and the TED50 DC. The CD60 is built of galvanized steel. It is our most economical choice. Next up is the CD50. That's built from extruded aluminum, so the blades and framing is extruded aluminum, and it's great for corrosive environments. So if you're near the near the ocean, or if you just want to make sure that those blades and frames will last a long time without corroding, the CD50 DC is a great option. And then finally on the right, the TED50 DC is also made of extruded aluminum construction, but this is a little more unique because it has a separate thermal break in between its blades. So there actually is not a thermal pass from one side of the damper to the other when it's closed. So for this reason, the TED50 DC is really best in cold temperature climates where the temperatures drop and you want to maintain that thermal break between your internal servers and the outside air. And so these models also have a new coupler option, which we'll discuss here momentarily. As I mentioned, the DC models have some new features. One of the unique features with these data center models is that they will no longer use any jack shaft crossover linkage when built in larger multi-section sizes. So you can see a picture here, the component, the crossover linkage that we're going to be removing. What this will do is it'll improve your damper performance because you have less moving parts when operated, which also will long-term help the life of that damper as well. So there's lots of different damper sizes in these data centers, but we have standardized on a robust 1-inch diameter jack shaft that will be used on all damper sizes for the internal mounted actuators because we're replacing that crossover jack shaft linkage. Another new option that we're promoting for the data center models are couplers that can actually join two damper sections together with a single actuator up to 30 square feet. So this option, as I mentioned, it would allow an actuator to be located on the side of a single damper frame, and you'll still be able to modulate both damper sections. And it maintains a narrow side profile when space conditions are limited. So you can see a quick rendering of what the new damper coupler option looks right there. And then typically for larger assembly actuators, we have this shows you what a multi-section would look like. So we're forced to be within the airstream on a jack shaft. For limited space conditions, such as a generator enclosure, the coupler option will provide a great solution by allowing two sections operate off of one actuator. And which then allows the actuator to be the side of the damper. So what you can see here is all of the actuators, because they can operate two separate sections, the actuators are located on the sides, making the center of those dampers a much cleaner look. We also wanted to highlight just a few projects that we've worked on recently. One thing that Ruskin is proud to promote is our engineering capabilities. So if you have a solution in the field, we would very much like to work with you to see if we can come up with a solution to help with that specific application. So recently we worked on a data center project in Virginia. And the customer here was concerned with keeping the indoor air temperatures maintained during the cold winter seasons. And what Ruskin, we saw this and what we provided as a solution was the TED50 XT with thermally broke frames to handle and maintain that thermal gap between the outside air and the internal building components. This project also featured the Ruskin Louver's ELF 6375 DXH that I mentioned earlier, and also Ruskin silencers to attenuate that generator noise. We also recently worked on a data center project in Iowa, and what was interesting about this project was there were very high space limitations. The customer did not have proper access to the dampers and actuators behind the louver face. And so the Ruskin sales team and the engineering teams, we collaborated with the customer. We came up with a louver design that featured 3 separate hinged access doors on each louver section. And these louver access doors allowed for maintenance personnel to get in behind the louver face and reach those damper and damper accessories. And finally, we also recently worked on a data center project in Oregon This data center project did require strict protocol to remain operational in the rare event of a catastrophic weather condition. Because of this, we did end up supplying one of our toughest louver models. It's the EME 5625MD, which is the Miami-Dade model. And we did this to withstand any threat of inclement weather to assure continuous operation. So, but again, while we supplied the Miami-Dade louver, this job obviously was not in Florida. So it's not uncommon for engineers to specify and customers to want the Miami-Dade rated louvers in many parts of the country, just due to its robust design in critical environments. This job also included the Ruskin CD60 dampers as well. So that summarizes most of the new information we wanted to pass on to everyone today. We appreciate you hanging on and listening to what we had to talk about. Just a few main key takeaways that we wanted to go off of here. First off, data centers represent critical facilities in an ever-increasing growing technological market. So they're not going away anytime soon, and they are important that we design them so that they can remain operational at all times. There are multiple HVAC systems that can be used in a variety of data center applications, so there's not a one-size-fits-all option, as Ghassan mentioned earlier. However, using 100% outside air is one of the more energy efficient strategies to cool your data center servers. Providing dampers with factory mounted actuators can reduce your labor time in the field and also simplify your labor coordination by having Ruskin provide factory mounted actuators. And then finally, Ruskin provides data center air control solutions through proven high quality louver, damper, and silencers. And so we'd be happy to help you with any of your data center needs that you may have. Feel free to reach out to your Ruskin rep if you come across these data center jobs, and we would love to work with you. So I'm going to pass it off to Tessa for a quick question and answer session, see what questions you guys had for us today.
Thanks, Spencer. So our Q&A session is now open. Please use the box on the upper right side of your screen to submit any questions you may have. We will respond to all questions we don't get to in an email following the conclusion of this webinar. If you have any further questions after the meeting concludes, please feel free to contact Emma Barnhart. So it looks like our first question is, do you see the actuators accessible in the AHU room or in the data center room?
Yeah, Tessa, I'll take that. That's a great question. So, typically those supply dampers or return dampers with the actuators on them, you typically want to make sure that the wall is kind of clean with nothing projecting out into it. So it really depends where you want to locate those actuators. Typically, they're not in the airstream, and what we've kind of seen a lot is that they might have an access door accessible from the data center, and you can access your actuator from there, but they could also be from the air handling unit. So really it depends, but the key is we don't want to project them into the data hall.
Right, thanks, Ghassan. So our next question is, where are the backdraft dampers typically located?
Hey, Tessa, I'll answer that. So when we think of our backdraft dampers, I think what we're likely referring to there is our relief dampers. Ghassan showed this in one of his slides. Typically, your relief dampers are going to be located near the top of your building. That's where the air is wanting to travel. It's wanting to travel upwards. So typically, your relief backdraft dampers are going to be either on your ceiling or on the wall near the top, close to the ceiling, is where you'll typically see those.
Right. All right. Thanks, Spencer. So our next question is, could we go higher velocity on some of these louvers and dampers?
Yeah, I'll take that, Tessa. So yes, we can. I know in the industry, we talk about 500 feet per minute as kind of a good number to reduce the pressure drop. So yeah, you could go higher. The Ruskin louvers are made to withstand higher velocity without carrying moisture or water into them. So you could go higher. The key is reducing your pressure drop, and that's basically the resistance across that louver and maybe the dampers. And so the less resistance you have of that air, the more, the less external static pressure you're going to have, and the less reduced horsepower you're going to have on your supply fan. And so that's kind of the key factor here. But if you've got a restriction in the space and the wall space, and you want to go less area, higher velocity, we can certainly accommodate that. We have the model numbers to use, as Spencer highlighted, that we could reduce. We can increase the velocity and still reduce any water carry into the airstream.
Right. All right, thanks. So the next question is, are the actuators typically field installed or factory mounted?
Yes, so this question was likely asked early on. In the end, I brought it up here. So actuators can be installed in either setting. They can either be installed at the Ruskin factory or in the field. We recommend that they are installed at the factory. The reason for this is sometimes the incorrect actuators are provided in the field, and then they need to be reordered. It's also much easier for them to be installed in the factory due to there not being space constraints, or the dampers aren't elevated. So typically coordination and ease of labor are the two main reasons we suggest if you can have these factory mounted, it is the best way to go.
Right. All right. The next question is, are the supply dampers typically 2-position or modulating?
Tessa, yeah, I'll take that. That's a great question. So typically those air handling units are going to have a supply fan that's going to be variable. You're going to vary the speed of that fan using an ECM motor or a variable frequency drive. So the question is, why do I need to have modulating dampers? Well, if you got multiple, so you're going to have typically a bank of air handling units, and you're going to have each air handling unit serving maybe perhaps some of these server racks. So you might want to direct the air to the right, to the center, to the left, and maybe those server racks are going to be loaded different. So you can direct the air, which is kind of like another tier of control, if you would. You got the air coming out of the air handling units, and I can direct it to wherever I need to direct it to. So sometimes we see those being modulating. Now, you could have a 2-position, and the 2-position will act as if you have an air handling unit, and let's say you take it off for maintenance. Well, you don't want the air to short circuit because these are module data centers, typically all wide open. There is no partition from one air handling unit to the next. So you don't want the air to short circuit. So having a 2-position damper would basically, when you take it offline, you would close the air and you would allow the air not to short circuit back to the mechanical room and direct the air where you need it the most into the server rack. And you could certainly do that with a modulating damper and just have it closed. So it really depends. We would recommend maybe perhaps modulating, depending on the layout for that.
Right. All right. Thanks. So it looks like we have one more question left, and it is, are the actuators typically in Airstream?
These are good questions. So just like whether these can be field installed or factory mounted, actuators on dampers can be either in or outside the Airstream. But typically for data center applications, if that's what they're asking here, those are more commonly seen out of the Airstream. So that's what some of the new features that we have on our data center dampers are lower profile and operate better with that actuator on the outside of the damper. So yeah.
Right. Thanks, Spencer. So those are all the questions we had from you guys, and we thank you attending for today's webinar. We will be sending out an email after the meeting concludes with certificates of attendance and a link to next week's webinar registration. That being said, please join us next week on September 23rd at 1 p.m. Central Time for our discussion on louver selection and specification. Thank you again for attending, and we hope you all have a wonderful day.